Hello and welcome to another video tutorial for the Flame Tracker application. In this video we will go over the Luma tracking method described in the wiki page Luma tracking. Let's say that we have a video of a spreading flame, like the example video in the repository, and we want to measure flame position, flame length, and spread rate variations. We saw how we can edit the video, and with manual tracking we could click on the flame location at different times to measure the flame spread. The manual tracking is useful for a quick analysis, but it becomes tedious if we have a large amount of frames to consider. The Luma and color tracking methods offer the possibility to track a flame in an automatic way, in the sense that I can set the initial parameters and then the flame tracker will process the video. I'll start by running the flame tracker and then I will open the example video. When I'm done, I can load the parameters from the CSV file in the same folder. As we saw in the previous videos, we need to correct the perspective of the video, and to do that, I select the first frame where I can see the entire sample. From the preview, I can see that the region of interest doesn't include the entire sample, so I need to select a new and larger region. If I click on the correction now, I see the four corners and I can click on them. If you need more information about the perspective correction, you can always check the video editing section of the wiki. Now I can change the first frame back to 1000, and then I select Luma tracking from Choose Analysis. The analysis box will get populated, and for example we have the flame direction, that in this case is right to left, and some parameters that we can play with. If I scroll through the video now, in the analysis box I see this image on the left that shows the lumen intensity of the pixels in the region of interest, obtained by transforming the original frame from the RGB to the YCB CR color space, and then filtering out the pixels with an intensity below a given threshold in the Luma channel. The intensity goes from 0 to 255, and the threshold is the one we type here in this box. Usually, a number between 10 and 50 is a good initial guess depending on the luminosity of the background. I can use the Go to Frame button to check the effect of the threshold on the same frame, or just simply scroll to another frame. In this video, a threshold of 15 seems to work pretty well. The image on the right shows the binary image obtained from the Y channel, showing in white the pixels that the program considers flame and in black the rest of them. It can happen that you select an appropriate threshold, but you still have small regions that are not part of the flame. In this case, you can filter the small particles out by using the slider of the particle size. Keep in mind that the maximum value of the slider corresponds to 25% of the total area of the region of interest. So if I change this region, it will change with it. The edges lines shown in the two images are calculated as the maximum and minimum locations of the flame region, but sometimes it is more appropriate to average these locations with more than just one pixel, and we can do that by changing the number of pixels in the relative box. If I want to check the filtered images a little bit better, I can click on Show Frames and two new windows will open with the frames. When I'm done, I can press the Escape key to close these windows. By the way, if I don't want to see the edge lines, I can just deselect the relative box. Once I am satisfied with the typical frame, I can check other frames with the preview slider. If the region of interest is large, there might be a little delay with the preview. And actually, it is always good to reduce the region of interest to a minimum to increase the speed of the video processing, since there will be less pixels to consider. If there is a flashing light in the video, for example to show the fuel surface behind the flame every second or so, I could select the flashing light box, and the automatic tracking will skip all the frames where the bright region is larger than half of the region of interest. This function is optional and we don't need it for this video. Now I am ready for the analysis, but to speed up the process, I will skip 9 frames. Since the original frame rate is 30, this means that I will consider 30 divided by 1 frame considered plus 9 skipped, so for a total of 10. So I analyze basically 3 frames per second. Remember that you can check the help button on the right of the preview box to check this calculation. All I need to do now is to click on Start Tracking. During the processing, the user interface will not be responsive, so until the process ends, it will not be possible to interact with it. However, I can check the progress of the tracking from the terminal window. At the end of the tracking, the 2 graphs in the analysis box show the variation of the edges position versus time on the left and spread rate versus time on the right graph. The difference of the edge's position is basically the flame length in this case, and you can interact with the graphs, for example, by dragging it with your mouse or zooming in and out, and if I click on this symbol at the bottom left, I go back to the original. You can also right-click on them and select log-log plots, for example, or directly exporting them. As you can see, towards the end of the experiment, the flame position seems a little off, and this means that something weird might have happened there. I can go back to the preview and check, but remember that whenever you do that, you will lose the tracking data currently in the analysis box. If I scroll to the end of the video, after frame 4050, I can see that the frame is extinguishing and the program cannot find it with the parameters I selected. Since the flame already reached the end of the sample, I can simply change the last frame to 4070, for example, and get rid of the final jump. Now I can track the flame again. Once it's done, I can immediately see that the range of the y-axis of the spread rate is much more reasonable. The data still looks a little noisy, and it's not clear if some flame changes are happening or it's just a processing issue. I can smooth the data by using a moving average, and I can select the number of points to consider in the relative box. Note that this number is not the total number of points used for the average, but the number of points to consider before and after a single frame. For example, until now we've been using 2, so we've been considering a given frame 2 frames before and 2 after, for a total number of 5. If we type in 5, this means we have a moving average calculated with 11 points. Since I am analyzing 3 frames per second, this means I am averaging the spread rate over about 4 seconds. The appropriate values for the moving average depend on your specific needs, and they could change with the speed of the flame and the frame rate considered, for example. This time, before I click on Start Tracking, I can select this box for the video output. This option will create an output video of all the frames considered, and if the edge box is selected, we can use it to check the tracking accuracy. The program uses the codec and format information from the preview box to create the video, but for this function, you don't have to worry about the frame rate because the program automatically calculates it. And now I can track the flame again. Flame location and spread rate look much smoother now, but there are still some jumps around 80, 100, and 110 seconds, so I can now check the output video to see what's going on there. The output video is in the same folder of the original video and its name has Y video at the end. I can open it and go close to 80 seconds, which is 1 minute and 20 seconds, and from here we can see how the flame has a little burst that pushes the flame edge ahead. This is a natural variation then, and not the program's fault, so at this point we can decide to keep it or rerun the analysis, for example by considering a smaller portion of the flame. What I mean by that is that I can select a new region of interest only for the upper side of the flame and track it again. Remember that if I change the region of interest, the filtering of small particles might need to be updated first, and it's always good to check the preview before the analysis. If I track the flame now, I can see that the spread rate variation is much smoother. Of course, the decision of what data is more relevant depends on your application. I can save the data from the tracking as a CSV file, and if I open it, I can see the measure edges location, spread rate, flame length, and area saved in this file, as well as some information of the video. If I want the edges location in absolute terms, I can click on absolute values, and the downstream edge, the right one in this case, will start from 0. Note that once you click on absolute values, you cannot retrieve the previous ones, so you might want to save the original data first. This concludes the tutorial of the Luma tracking method, but remember that you can always use the help button to get more information about the analysis box. Thanks for watching and good luck with your analysis.